Have you ever stopped to wonder how all the software you use is actually built? At its core, it really boils down to two master blueprints that engineers use to build literally everything. And today, we're going to break them down. But first, let's start with a bit of a riddle. What on earth could a recipe for a chocolate cake possibly have in common with that app you spend hours on every day? It sounds kind of weird, I know, but the answer really gets to the heart of our whole conversation.
And the answer is they're both built from a really specific plan, a blueprint, right? You wouldn't build a house without one, you can't bake a decent cake without a recipe, and you for sure can't write software without a solid plan. We're about to explore the two biggest, most dominant blueprints in the entire programming world.
So on one side, you've got procedural programming. Just think of it like a super detailed, step-by-step recipe. And on the other side, we've got object-oriented programming, which is way more like putting together a team of specialists, where each one has a very specific job to do. Two totally different ways of thinking, both trying to get to the same finish line.
Okay, let's dive into that first blueprint, the procedural recipe. The whole idea here is just following a set of instructions in a straight line, right from the top all the way to the bottom.
So what is it really? Well, procedural programming is basically an approach where the program is just a sequence of instructions. The main focus is all on the steps, the actions the computer has to perform. You're thinking in a straight line. Data comes in, a bunch of steps happen in order, and an answer comes out. Simple. It uses this classic top-down approach. You look at the big problem, you break it down into smaller, manageable chunks called procedures, you write out the instructions for each, and the computer just chugs along, executing them one after the other. It's logical, it's direct, and it's actually pretty easy to follow.
And that simplicity, that's its biggest strength. It's super simple to pick up if you're a beginner, and for small, straightforward tasks, it's really efficient. But here's the catch. Just like a simple recipe turns into a total nightmare when you're suddenly trying to cook a 100-course banquet, this whole approach gets incredibly hard to manage as your programs get bigger. Data ends up all over the place, it's not very secure, and trying to reuse a piece of your code for a different project? Yeah, good luck. It's tough.
So what happens when that recipe gets way too complicated? You don't just keep adding more and more steps. No way! You've got to change the entire strategy. You stop being the lone cook following a recipe, and you start acting like a head chef, assembling a whole team of specialists. And this is where object-oriented programming, or OOP, as you'll hear it called, comes into play. With OOP, the focus shifts completely, away from steps and towards things. The software is organized around these little bundles called objects, which are designed to represent real-world things. Like a customer, an invoice, or a shopping cart. Each object holds onto its own data and knows how to perform its own skills. It's all bundled together in one neat, self-contained package. But you can't just throw a bunch of specialists in a room together and expect magic to happen, right? That would be chaos. You need rules. And in the world of OOP, the whole system's success hinges on 4 key principles that dictate exactly how these objects, our specialists, are supposed to work together.
All right, principle number 1 is encapsulation. Think of this as like professional privacy. Each specialist, each object, keeps its own tools and its secret techniques private. A master baker isn't going to share their secret family recipe with you, right? You just go up to them and ask for a cake, and they give you a finished cake. It's the same idea here. This protects the object's important data from being messed with from the outside.
Next up, we have abstraction. This one is all about hiding the messy details. You only need to see the simple, essential controls for a specialist, not all the complicated stuff they're doing behind the scenes. I mean, when you press the bake button on your oven, you don't need to understand the thermodynamics of the heating coils. You just trust that it's going to get hot. That's abstraction. Then there's inheritance, which is absolutely brilliant for being efficient. This lets you create a new specialist that automatically inherits all the skills and tools from an existing one, and then you can add its own unique abilities on top. For instance, you could say a pastry chef is a type of baker, so they know how to do all the basic baker stuff, but they also have specialized dessert skills. It means you're not constantly reinventing the wheel. And finally, the fourth one is polymorphism. Now, that sounds like a mouthful, I know, but it literally just means many forms. And the idea is super powerful. It lets you give the same command to different specialists, and you can trust that each one will do that action in its own unique, correct way. You can tell a baker, a butcher, and a salad chef to prepare food, and they'll all do something totally different, but it'll be exactly what you'd expect from each of them. So this team approach, It's amazing for building big, complicated systems. The code is reusable, it's way easier to manage as it grows, and your data is much safer thanks to encapsulation. So what's the trade-off? Well, there's a steeper learning curve for sure, and if all you want to do is boil an egg, assembling a whole team of master chefs is, well, it's massive overkill.
So this brings us to the crucial question. Which blueprint do you choose? When do you go with the simple, straightforward recipe? And when do you call in the powerful, but more complex team? Let's put them head to head. You can see the difference right away. The procedural recipe is all about the steps and the actions. OOP, the team, is all about the objects and how they interact. With the recipe, data is often just out in the open, kind of a free-for-all, which is less secure. With the team, it's safely locked away inside each object. So, here's the bottom line. For simple scripts and linear tasks, the recipe is your winner. But for large, complex systems that need to grow and change over time, the team approach is really the only way to fly.
Okay, so why does any of this actually matter to you? Well, because whether you realize it or not, you are completely surrounded by these two blueprints every single day. They are the invisible architecture of the digital world we all live in. And here's the real secret, the key takeaway from all of this. In the real world of modern software, the best builders, they don't pick one or the other. They actually use a mix of both. They'll use the object-oriented team approach for the big picture structure of an app, but when you look inside each specialist's to-do list, those individual tasks are often just simple, procedural, step-by-step recipes.
So I'm going to leave you with a final thought, a little challenge. The next time you open up an app on your phone, just take a second and ask yourself, does this feel like I'm just following a rigid step-by-step recipe? Or does this feel more like I'm interacting with a whole team of specialists all working together behind the scenes? I think the answer might just